Implicit differentiation, part 2. Remember that for implicit differentiation, we need to differentiate. Remembering that when you differentiate y with respect to x, we have to remember to multiply by our dy dx due to chain rule, and then we solve for dy dx. So let's find dy dx if x cubed plus y cubed is equal to 2x plus 2. So we'll need to find the derivative with respect to x of x cubed plus y cubed is equal to the derivative with respect to x of 2x plus 2. So that's the derivative with respect to x of x cubed, which will be equal to 3x squared, and then the derivative with respect to x of y cubed. So our outside function is cubing, so we have 3 times our inside function of y and then squared, and then times the derivative of y, so dy dx, just using a bit of chain rule. Then we have the derivative with respect to x of 2x, which is 2, plus the derivative with respect to x of 2, which is 0. And now, in order to find what dy dx is, we'll have to solve for it. So we'll want to subtract the 3x squared from both sides, so that on the left side, all we have is this 3y squared dy dx. So that'll be equal to 2 minus 3x squared. And we're almost done. In order to isolate that dy dx, we'll have to divide both sides by 3y squared. So dy dx will be equal to 2 minus 3x squared all over 3y squared. We want to find the derivative of y with respect to x if sine of y is equal to xy. So we'll find the derivative with respect to x of both sides of this equation. The derivative with respect to x of sine of y will be the derivative of the outside function, so the derivative of sine, which is cosine, with y still in it, times the derivative of y, so dy dx. And when we take the derivative of xy, this is a product. We have x times f of x, so that's two functions being multiplied together, because y is f of x. So we'll have to do the first function, x, times the derivative of the second function, so the derivative of y, which is dy dx, plus the second function, y, times the derivative of the first function. The derivative of x is 1. So we have cosine of y dy dx, and here's one of our dy dx's, is equal to x dy dx plus y. But we want to know what just dy dx is, so we need to solve for it. So we want everything with a dy dx on one side of our equation, and everything else on the other. So we'll subtract x dy dx from both sides. And we have cosine y dy dx minus x dy dx is equal to y. Now, both terms on my left side have this dy dx, so I can actually factor it out. So I have dy dx times cosine of y minus x is equal to y. And I'm almost done. This dy dx is being multiplied by this entire cosine of y minus x, so I can divide both sides by cosine of y minus x, which gives me that dy dx is equal to y over cosine of y minus x. So implicit differentiation is very similar to regular old explicit differentiation. We just have this new multiplying by dy dx when we take the derivative of y with respect to x, and then having to solve for it. But it still follows the product rule, quotient rule, chain rule, and our regular other rules for differentiation. Find dy dx if cosine of x is equal to e to the xy. So we need to find the derivative with respect to x of cosine of x is equal to the derivative with respect to x of e to the xy. Now e to the xy is kind of interesting because we have both chain and product rule. So we have e to the xy. So our outside function is e to the x, and on the inside we have this product of x and y. So we'll have to be a bit careful. The derivative with respect to x of cosine of x is equal to negative sine of x. And then to find this next derivative, we'll have to use chain rule. So we have e to the xy. That's the derivative of e to the x with the inside function, that xy is still there. And then we'll have to multiply by the derivative of xy, our inside function, which requires product rule. So that'll be the first function x times the derivative of the second function, so that's dy dx, plus the second function y times the derivative of the first function. The derivative of x is 1. And now we want to solve for this dy dx. There's a couple different things we could do. We could start by dividing both sides by e to the xy, but that's going to lead to some having to combine or find a common denominator and combine some fractions, which is a bit of a mess. So it's actually a little easier to start by distributing the e to the xy. So we have negative sine of x is equal to x e to the xy dy dx plus y e to the xy. So I just distributed my e to the xy, which I didn't leave much room to draw arrows, but there we go. And now I'm still solving for this dy dx. So I'll make sure that the term with my dy dx is the only one on that side by subtracting y e to the xy from both sides. So I have negative sine of x minus y e to the xy is equal to x e to the xy dy dx. And now that's x e to the xy times dy dx, so I can divide both sides by dy dx. So I have negative sine of x minus y e to the xy all over x e to the xy is equal to dy dx. And I've solved for my derivative.